Hello and welcome to my first of, I would say, quite a few videos on building a CNC. Yep, I've gone and done it. I've bought myself finally my own CNC. So first off, what is a CNC? CNC stands for computer numerical control. It's a method of controlling something, anything, be it a pen, cutter, engraving tool. It's a method of controlling anything via an axis using code, commonly known as G-code. The machine that I've bought has what we call an Y-axis. X-axis is commonly left to right, right to left. Y-axis is commonly front to back, back to right. Z-axis, or Z-axis, as the Americans would say, is up and down in the Z. Think back to your school days when you were doing graphs and maths. You had your X, Y coordinates and you plotted out charts and things like that. It's similar to that. Add on top of that the Z. And basically that's what you've got. So when you've got a part, if you want to design and make something like that, for instance, you'd set your datum point X0, Y0 there, or here, or in the middle. And then if you program it, for instance, go to X20, Y20, it would move 20 mil, 20 millimeters in the X, 20 millimeters in the Y, or 20 inches, 20 microns, 20 thousandths of an inch. It depends on how you program it initially and the machine is set up initially. That's essentially the basics of it. On my YouTube channel, I made a couple of pub signs for a couple of subscribers, which went down really well, and I made my own one, but it's quite a lot of hard work, hand routing them, hand engraving them out. So I bought a CNC primarily to do some pub signs for some subscribers, and we'll see how it goes. I'm also looking at next year getting rid of my car, maybe getting a small van, converting that into a camper van, so I'll be designing and building that myself, the units and cupboards. The machine I've gone with is 1500 by 1500 bed size, so that's the actual bed size. 1.5 metres by 1.5 metres size with a small Z, and I'll be primarily engraving wood. It may be out of cut metal. If you look at the badge here, you'll see the company I've gone with, Rat Rig. The reason I went with Rat Rig is because the way that it runs is what's called a linear rail. A lot of companies make their CNC machines small hobby machines, which this is. A lot of companies use little plastic wheels. I think a linear rail is a bit of a sturdier and more solid and more it should have a longer shelf life using a linear rail. I'll show you in a minute what a linear rail is. But first of all, let me bring the camera in and show you. I was a little bit overwhelmed. First off, let me just say, so far the service from Rat Rig has been brilliant. I could have bought, and maybe I should have bought, a CNC from the UK, but Rat Rig here in Portugal, the service was brilliant. The delivery and postage was brilliant. And so far they've been as good as gold. I'll bring the camera in a bit closer, scan around a few bits and bobs that I bought with my kit, and then I'll take you down the bottom of the garden. I'll show you the linear rails and the project I'm doing today. This series of videos is not going to be an in-depth, every single step of the way, this is how you do it series of videos, because it will go on forever and ever and ever. There are literally bags and bags of tiny nuts and bolts. Luckily they're all labelled up, so try not, if you do get the same kit as me, you try not to sort of rub that off because you could be lost. Hence I bought myself a digital vernier there, so I can measure up if it does sort of rub off, so I can know what I've got. I've already made a start on it, so I'll bring the camera in close and I'll show you what I've got. When you first undo the box, it's quite overwhelming. I've just literally started making it. You can see I've bolted a few bits together, that's about it. And I'll take you down the bottom of the garden, I'll show you the linear rails I've started on already. That's the Z, the small Z axis on the linear rails with the lead screw. And basically, as I said, I'll bring the camera in and show you what you get when you open the box. There's a few empty bags here. We'll get rid of these because we've already done with that. Let's bring the camera in, I'll show you what I've got, and then I'll take the camera down to the bottom and show you what I'm doing, what the stage I'm at now at the moment. But with the linear rails, what they call a C-section. So as I said earlier, a little bit overwhelming when you first open the box. Some printed parts in here. I bought a table with mine as well, so I've got adjustable feet for the table, some shim that needs adjustment. This is what they call a C-section, extrusion, hence it's the C shape there. So I've already made these plates up, one there. I think the plate is, this is for the Z. This one is for the, I do believe, the X. And what you do, you bolt these 2 blocks on, these threaded blocks, and then the lead screw drives through that. That's fixed. That gets driven by what's called a stepper motor. It'll move that on the bearings on these ground linear rails. I've done the 2 side plates here. Same again, blocks there, blocks there. Everything's labelled up. The instructions are on the website, the Rat Rig website. Full instructions on the website, which so far have been okay. When you open the box, it is overwhelming. Tiny bags of everything you need. Spindle bracket. I think the spindle's going back. I've got a router, but I might be changing that for a different model. Washers, brackets, cabling, wiring, micro switches, power supply there, which powers the 240 volts down to the controller. This is what's called a controller. I've gone for the Duet 3. I'll take all that off. Controller. As I say, it's quite an in-depth kit. Washers, brackets, tracks for you running your cable in. Let's go around here. Stepper motors, 4 stepper motors. I do believe one is for the Z, one is for the I'd say the Y, and I think there's 2 for the X axis, which drives it back to front, I think, or vice versa. Is that right? I'm thinking out loud now. So I'll just show you what a stepper motor is. This is one of the motors. A mini stepper motor. If you know anything about CNC machines, you'll see that this is a mini stepper motor. What a stepper motor does, I do believe it takes electronic pulses and it will move just certain, instead of just running completely, spinning around, it will just step, hence it's called a stepper motor. Tiny movements, and that tiny movement that will then move the lead screw, which in turn will move the X, Y and Z. So let me just take you down to the back of the garden and I'll show you the lead rail set up and what I'm going to be doing in the next couple of days. As I said before, this will not be a series of videos in depth every single nut and bolt. It's quite a comprehensive kit. The service I've received from Rat Rig so far, it's early days, has been good. The parts are so far all here. I've not checked through, there is a checklist, but there's so much to check. I'm just taking it as it comes, to be honest with you. Yeah, Rat Rig service has been really good. They've got quite an active Facebook group if you want to pop onto the Facebook group and have a chat. They email me when I queried about the router that I bought. They emailed me and put my mind at rest. I wasn't too sure about the Duet 3D, but the Duet 3 controller, they put my mind at rest with that, so I'm keeping that. The router I might be sending back and changing for a spindle. But I think I've got everything I need. I need to build an enclosure because the electronics need to go into some sort of enclosure box. So I might hunt around and make, or buy off Amazon some sort of metal or plastic enclosure to put all the electronics in. I've got to build the whole lot from scratch. As I said, literally tiny nuts and bolts and screws. Everything's labelled up. So far all I've needed is an Allen key. But it's early days yet. I'm assuming I'm going to use a spanner at some stage, but pretty much everything's like cap head screws. So I'm assuming it's all Allen keys. I've got, in particular, I've got the aluminium extrusion down the shed, down the garden bar, which will make the actual machine up. I've also paid extra for a table. They do, for what it was worth, the table I think was a couple of £200 or £300. For what it was worth, I bought the aluminium table they supply, which comes slightly bigger than the machine I bought. You just put a sheet of MDF or chipboard on top of that. For the money that cost, I think it was quite a good deal, because to build a solid table with wood nowadays is going to cost you a couple of quid anyway. As I say, so far the service has been really good. What you don't want to do is move these about too much and they're not rubbing off your marker pen. But I mean, all credit to them. Someone sat there and put all these bits and bobs in little bags and labelled it all up. I suppose the idea is where you save the money is, because it's quite a good price, these machines, where you save the money is you're building it yourself. You haven't got someone else to build it for you, because you're looking at a good couple of weeks work to do this, I would have thought. So I want to start doing it at weekends and in the evenings. As I say, So this series of videos will not be literally hands on how to do it. It will just be a video every now and again at the different stages I'm at, a few hints and tips for people that are doing a similar job. If you want, follow these videos through from beginning to end, and it'd be nice to see me struggling like now with these nuts and bolts. I'm looking forward to the end result, and hopefully you're looking forward to the end result when we've actually got a machine up and running, working in X, Y and Z and cutting metal or wood, predominantly wood engravings. I've got a couple of projects in mind, some bar signs in mind already. I may do some work for some, as I said, the van, if I get a camper van. I think I'm doing like a memorial wooden plaque for my father who passed away last year, so that'll be one of the projects I want to do. Predominantly at the moment, wood's in short supply. Getting hold of sheets of wood in the UK at the moment is quite a short supply, quite expensive, but I'm looking at birch plywood for outdoor signs, coated up, or whiskey barrel lids to engrave up for pub signs and bars, scaffold boards for pub signs as well. As I say, I've got a controller board which is the brains behind the outfit. Power supply which puts power through to the controller board, and the motors which drive the mini lead screws, and we've got a linear rails here. I'll take you down the garden and show you the linear rails. Feel free to comment. Feel free to post below in the comments any questions, any comments, any advice. If you've made one of these yourself, feel free to give me some advice. I can't give any hints and tips at the moment because I'm just at the first stages of it. As I said, I've only just made up these blocks. Sort of, as you build it, as you go through it, you come up with some better ideas. The instructions are quite basic, but you need to line these blocks up with a thread. But I'm sure once it's all built together, you can tweak it and trim it up. Let's go and have a look at the linear rails, and let's carry on. I'll show you what I'm doing down the bottom. Nightmare job. M3 cap head screws, 10mm long, through a lot of little holes on the linear rail, screw them up. I'll take the camera down there. Let's go and have a little look at what my next project. That'll keep me busy for today. As I say, comment below, ask questions. I've learnt a little bit already, so you know, during the week I'm going to be building more and more. Any problems I hit, I'll be going on the Facebook group, bending areas, I'm sure. Wiring, I've got to do that yet. I know nothing about wiring really in electronics, bare minimum. So, and as I say, I want to send a round back and get a spindle, I think, with a variable control speed on it, and it can take some bigger collets. Let's go down the bottom and look at the linear rails. So here we are, down my shed, garden bar. If you watch my videos, you know that I've got a pub shed down my garden. It's the only place I've got to store this at the moment. So this here at the moment, this here is extrusion for the table that I've bought. This here is the actual beams for the bed, the machine bed, the actual rail to the machine. And these are what are called linear rails. So this is a steel ground rail with a bearing block on there. I think there's roller bearings in these. The other type you can get uses plastic wheels. I mean, I'll be predominantly cutting metal, so plastic wheels I think would have been fine, but I've gone for a slightly better option, I think, and a slightly longer lasting option. I must admit, the other type with the plastic wheels you will wear, but you can probably change the plastic wheels over. These should last forever, as long as you keep this clean, because these are greased up. As long as you keep this clean it down, blow it down with an airline or a little air canister or something, keep it all clean, stop the dust getting inside there, but obviously you can replace these at a later date. I'll take one of these out. What the plan is at the moment, what I've done so far, you put one linear rail on each beam. When you put the second one on, you leave it loose. Then the pieces I showed you indoors just now, the rails, the side pieces, the steel pieces, you put that on, run it up and down at each end, and then you tighten up the second rail, so that way it runs freely. There's one there, it runs freely. I'll show you that in a minute. I'll show you what I'm doing now, because I've got to do another couple of these today. I'll show you how they go on. So this is the method I found works for me. Down the garden, under the gazebo, before you can be in your workshop, be anywhere you want. But I found if you sit across a chair like this, the C-beam, which is here, sitting on the arms, the linear rail is still in its bag at the moment, greased up. So I need to fit at the moment on each C-beam one linear rail. Because I bought a 1500 by 1500 machine, obviously all four sides the same length, apart from the Z, but the four, sorry, two lengths in the Y and one length in the X So you got the Y like this, and then the X running this way. So the two lengths of extrusion, C-beam extrusion, in the Y are the same length, and then the X is the same length. But what you do apparently on the instructions, depending on what machine you bought, you marry up and you pair up your linear rail with your C-beam, because they'll basically be about the same length. They're about 1 mil shorter. Your linear rail is about 1 millimetre shorter overall than the beam, just offset. So what I'll do, I'll cut this out of the bag first of all, without scratching it. All greased up. I did have a bit of kitchen roll down there the other day, but I've lost it. But I just want to show you me doing a few of these, and then I'll turn the camera off and you can come back later and I'll show you when it's finished. So let's take that out of there, all greasy, which is good, which is what you want. Throw away the plastic bag. So there you have the rail. That rail sits on either side of the top section of the C-beam, like so. My job now, sadly, I'm going to say what I do, I move that beam away. My job now, sadly, this beam can go up, out the way. What I need to do now, if you look at this rail, is fill every single hole up with an M3, which you get in a bag here, and a bag here. I get extra ones because I bought the bigger machine. So you fill the holes up with an M3 by 10mm long cap head screw. I'll just do one for now because it's quite a long task. You literally just drop one of these in every single hole. You don't do the two end holes at the moment. You don't want the bearings running off the ends, so you leave the two end holes filled up. You've got two plastic stoppers in the end, leave them into the end of the job. 3mm screw dropped in there. On the back of that, you screw, I'm not quite sure what these are called. There's a name, I think they're called dropping washers. So I'll bring the camera in to show you close up in a minute. If I can get them out of the bag, I'll probably tip these into a little cardboard box in a minute. So we get a dropping washer, like so. You can't see it from now. I'll bring the camera close, and then you have the two grippy pieces facing upwards. 3mm Allen key, 3mm cap head screw, 10mm long, couple of turns. That's now fixed on like that. You just want a couple of turns. Leave it loose. I'll bring the camera in and show you it up close. I'll turn the camera off. I've got to do every single hole, apart from these two end ones, which are plugged up with plastic plugs. Then I'll bring the C-beam down on top of my lap across here and drop that on. Then you tighten them all up. When you tighten them up, I'll show you up close. When you tighten it up, in the box you should have two of these 3D printed alignment pieces. So what happens is you click that on top of the rail, the linear rail, on top of the beam, and that helps align it. You do one end, and what I was doing yesterday when I did a couple, I was sliding this along the rail, doing the screws up as I went, keeping it nice and straight, nice and square. As I say, when you do the next linear rail you leave loose. The part that goes on that, you sit on that, you run that up and down, and then you tighten it up. So that part then moves freely. I'll bring the camera in close, show you what I mean by these little dropping washers, little dropping 3mm screw dropping washer. Then I'll do all that, and then I'll show you how it goes onto the beam. So the camera's up close now. Excuse me. 3mm by 10mm long. Obviously this is for this kit only. If you buy a machine, it might be from a different manufacturer, different company. So what I'm going to do, what I've been doing initially, I'm do one now just to show you guys and girls, but what I've been doing is filling up a whole array of holes in front of me, doing all that batch. Using the 3D printed part as a marker so I know where I am, won't be way long, turn it around and do another batch. I'll just show you do the one at the moment. So what you do, you simply drop the screw into the hole, 3mm screw, take your, what they call dropping washer. Now these can only go, well they can go up both ways, but you only want to put these up one way. If you can see that. You have the grippy There's a grippy section there, grippy section there. And let me just put that, you can see that there. Well, that's the way up you want them, that's facing upwards. And you quite simply, I'm trying to do this sort of with the camera at the same time, get a couple of turns with a 3mm Allen key so it hangs on. You don't want them dropping off, but you don't want them too tight. If they're too tight, you won't be able to get it in your C-beam later on. There you go, and that's ready to drop in the C-beam into the extrusion, into a section of the extrusion, and then you tighten them all up. What happens is, when you tighten them up, this piece turns that way and locks up to the extrusion. So without further ado, I'll turn the camera off. I'll see you tomorrow. Now, all joking aside, I'm going to fill this end up at the linear rail with screws, put the washers on the back up the correct way, spin it round, do the other end. Then I'll switch the camera back on and I'll film myself dropping it into the rail and I'll show you how we do it up. So I'll see you in quite a while's time. Thank you for watching so far. So that's that done. They are all screwed in a couple of turns. Just give them a couple of turns, enough to hold them onto the 3mm screws, not enough that they fall off. It takes a little while, and as I said, I haven't done a two-end one because you've got plugs in there to stop the bearings sliding off. You then grab your C-section extrusion and you're putting the linear rail into just one of these slots first. So you literally just sit that on top like so, and if you turn it up like that, you can see that a few of them drop in because of the shape of them. They drop in the slot, some don't. So what you do, you just tip it over and you get your Allen key and you just give them a little twist with your Allen key to line them up so they drop in. That has dropped in, and now that is flush to the extrusion, if you can see that. You've got a slight, about 1 millimetre shorter than the extrusion, so you take your, that's in the bag of 3D printed parts. You start at one end, you take your rail, you put this piece over the top like so, just line it up at the end there, and then you do your first one up. Might be quick with an electric or battery screwdriver. You tighten that up. And what I do both ends, but what I've been doing is do one there in the middle, and as you do it up, it pulls the washer up to grip like so. And you go down to the other end, you spin it round, you get two of these. You don't really need to be fair, but you can put one at either end, but you put one that end there like so, on there, if you can see that on there. That aligns the rail with the extrusion nicely, and then you just give it a spin with your Allen key. That pulls the washer up, the drop-in washer. Do that nice and tight. Do the other one. So I'll leave you now. I'm going to tighten all these cap heads up. I'm going to do all the extrusions. As I said earlier, I'm only going to do one side at the moment. You only do one side tight, then you put the other one on loose. So I've got to get all the other extrusion, all the other linear rails, all the cap heads in, 3mm by 10mm long, with the drop-in washers. Put them on the back end. All the other linear rails go on loose. So once you've got one linear rail on each extrusion piece of the correct length, You then put the other linear rails on the other side of the extrusion, but you leave that loose, and I'll come back to you when we go to do that, because what you do with that one, as I said before, you put the necessary plate or whatever is running up and down on it on, then you run that up and down. So as opposed to using these, you're using the actual part that's going to run up and down on it. So that those rails then will run nicely, and then the piece then, when you build the CNC up, the piece then will run up and down the rails nice and smoothly. That's the plan. So I'll see you in a bit. I'll let me do all these rails, and I'll probably catch you up when I put the other piece up, and that'll be the end of this first video, I think. Thank you for watching. So all the carriages, the aluminium extrusion rails, the C section extrusion, I've now had one rail, linear rail put on all of them to marry up the same length, or match up the length. Now I'm going to do the same again with the next set of rails. Drop the screws in, put the back washers on, drop it into the extrusion. But this time what happens is, you grab a plate, one of these plates, a carriage plate. These particular ones will run on the y-axis, and they'll carry the X beam. So they'll run on the Y and carry the X beam there. So I've got two of those go either side, and then another plate in the middle which will drive the Y. And as it said in instructions, as long as you put it in with the blocks, with the thread inside the extrusion, you can't go wrong. So what I'll do now, I'll fill this one up with screws again and washers, drop it into the extrusion. I'm going to show you how to set that up. Just a point to note and a reminder that when you're doing these washers and screws through the rails, give it at least a couple of turns. Not too much that they won't drop in the extrusion, not too little that they'll fall off. What you don't want to do is put the rail on. You don't want any of these falling off inside the extrusion. That means you've got to take the extrusion, the whole thing off the extrusion and start over. But so 2 turns should do it with the Allen key. Put it on like that, quick spin, done. As I said before, you can use that as a marker so you know where you are, you know which ones you've done, which you haven't done. Do the end one. So same again, another one completed, all the washers in, and we slide that into the rail, the extrusion, sorry. And that should just sit in there like that, as we did before. Again, you have to spin the washers around to make sure they sit in. Spin that one around there. And it should drop in. Spin that one around there. A couple of proud. I'll just a little spin the Allen key. Nearly done. There's one just stopping it up there. Right, that's in. This piece here, for instance, one is for the Z, or one is for, I've bolted these blocks on already to take the lead screw. One is for the Z and one is for the Y carriage. So I've put one on the Z already, but my Y and my, sorry, not the Y, the X, my X and Y are the same length. But on your particular machine, you need to work out what's your X and what's your Y and where that one goes. So that's got to go on one. But what I'm going to do first, I think I'm going to do this. Excuse me. So this plate, basically what you do, you bolt that facing down with these inside the section of the extrusion onto the 4 linear rail carriages, like so. So what you do, you sit that on there like that. The general consensus from what I've gathered so far is, if it's got a counterbore, you don't put a washer in. If it hasn't got a counterbore, you put a washer on. So on this at the moment, I do believe on here we're using 3mm M3 by 12mm long cap heads. There's 16 screws going in there. So let's get a couple of these. So far we've used M3s and M3 cap heads, which is quite handy. So what we'll do, we'll put that onto the 4 carriages, which are on the linear rails. We'll line it up with the holes. I can see the holes. Like so, get one in. Oh, I forgot the washer, so I've got to put a washer on there, but I'm just going to nick one up to hold it in place. Is that in? No. Get the thing lined up. Right. That's it. So I'm just going to put that in place while I grab some washers. M3 washers. Some people say these are black, some people say they're getting silver washers. It doesn't really matter. So put a washer on each screw. I'm just going to put a couple of screws in for now, and I'll show you how it goes. So, bam, you know what's going to happen. I'm not sure if we've got spares. Right, washer, screw. In the hole, I think. Where is it? Right, remember, at the moment the rowel is loose. One rowel's fixed, one linear rowel's bolt is screwed up, one linear rowel is loose. So put a screw in there, screw in with some washers. So what you do, the plan is you tighten that up. Don't have to put them all in yet, but do a section. So I thought I'd put 2 washers on this. So get your screws in tight, like so. Take this one out. Put another washer on there. So the idea is this plate is bolted down to the carriages which run on the linear rowels. So you bolt up all 4 carriages with the screws, with the washers. So M3 washers, M3 cap heads, 12mm long. The other plate for the other axis uses a different size. I'll get a couple more out and I'll show you what happens. So basically, when all 4 carriages are bolted up to this plate, with all the screws, what you do then is run it to the end. You don't use the printed part anymore going forward. You use this piece. I'll show you what I mean. Get a couple of screws in there, a couple of screws in there. I'll just put one more screw into here, into this carriage. I'll line it up with a hole. Right, that's lined up. Screw washer, screw washer. So I'll just put 2 in each for now, which will suffice, I think. Just keep all square. And I can show you what I mean. So put that down there, put that down there. So you do need to put all 16 screws in really, but I'll just put a couple in each for now to square it up. Tighten that, fully home. So when this plate is fully on, you do this for all 3 plates. Well, actually all 4 plates. 2 for your Y, 1 for your X and 1 for your Z. Now that's screwed up like so. You now run this to the end. I'll bring the camera. Getting heavy now. You now run this to the end, like so. About there. check you're not overhanging the edge. Then you tighten that screw up. Now the instructions say run it to one end, then run it to the other end, tighten those screws up, but there's nothing wrong with you using this as a guide now. You can slide this up and down and tighten up a screw every now and again. And basically what it does, it'll make sure that your rails, your linear rails, are in line with each other, and nice and square. So run that up and down. Like so. So I've done this screw up here, I've done this screw up here. So from here to here. That should run freely, which it pretty much does. You run it to the other end, or even to here for instance. You don't need to run it to one end, just run it up and down. Do your screws up as you go. Back to the end. So there you have it. I've not put all the screws in yet, but there you have your first. That's your y-axis with your plate bolted up. I'm going to leave you now. I've got this one to do, 3 more to do now. 2 for the Y, 1 for the X. So that should keep me busy. I've already done the Z. God. Supposed to work this. It's going to take me a while, just got to keep going. Might have a matter. Can't know how many screws it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know, 40 screws per linear rail. I'll cope. This will take me a good couple of hours to put these screws in, I think. So I'll see you next video. Hope you've enjoyed this video. If you found it a little bit interesting. Next part would be doing the Z, and I'm going to follow through bits and bobs. I'm not going to do in-depth videos, but it's going to take me a good couple of weeks, I think, to get this one. So there you go. All the screws are in now. The linear rails are screwed up tight. The plate's screwed on tight on its 4 carriages on the 2 linear rails. That runs up and down the flats. It makes a bit of a noise because obviously on the hollow extrusion at the moment it's not. But that's running quite well. I might shim it and tweak it at a later date, we'll see. Ta-da.